When you look at raw river gravel, you are looking at gold trapped inside a matrix of cemented mud. Stripping away that mud requires a systematic approach to agitation and flow. Extracting gold from sand is simpler than rock mining because the gold is already loose. You just need to follow a four-stage protocol to isolate it. The process begins with these physical prerequisites: a bulk supply of raw sand, a high-volume water source, a screening mesh, and a finishing pan. Following these four stages allows an operation to process massive volumes of earth with high efficiency. Let's look at the mechanics of turning raw material into a concentrated asset. Stage 1 is crushing and screening. Alluvial gold often arrives attached to pebbles by cemented mud. If this bond isn't broken, the gold is carried out of the plant and lost during the initial screening. Industrial operations use large trommel screens to agitate the material. On a mining ship, these cylinders rotate to crush mud while washing gravel simultaneously. Screen sizing is critical, using holes between 10 and 20 millimeters. Anything over 100 millimeters is diverted to waste. To break down the cement, for every cubic meter of sand, you must cycle between 8 and 14 cubic meters of water. This volume must be delivered at a specific pressure. Maintaining at least 35 kilopascals inside the trommel ensures the mud is fully stripped. Using incorrect screen sizes or insufficient pressure means the gold remains trapped, resulting in valuable material being thrown away with the waste rock. With the oversized rocks removed, the focus shifts to the fine material left behind, specifically particles smaller than 0.1 millimeters. This fine silt is known as floating gold. It is almost impossible to recover and contains very little actual value. This material must be removed because it interferes with the physics of the plant. These tiny particles stay suspended in the water, blocking heavier gold flakes from sinking and settling. Running the material through a mud hopper desludges the mixture. However, if you are using a high-capacity chute for the next stage, the force of the water is often enough to handle this silt. Purging this fine interference ensures that the heavy gold can separate cleanly based on its weight. Stage 3 is separation. This relies on gravity to pull the heavy gold out of the moving sand. In a traditional sluice box, the water speed is tuned so the sand stays in motion while the gold sinks. Because gold particles vary in size, a modern processing line uses a sequence of different gravity equipment to capture both coarse and fine grains. After the machines have created a heavy sand concentrate, the final recovery is often done manually. You place the concentrate in a pan and submerge it just below the surface. This requires elutriation, a rhythmic swirling motion that keeps the sand in a state of constant agitation as you swirl. The lighter sand is washed over the edge of the pan. Eventually, only the heavy gold remains at the bottom. While industrial mines might use magnetic separation or amalgamation cylinders, manual panning remains the standard method for finishing the concentrate. From historic wooden sluices to precise manual elutriation, gravity remains the most effective mechanical principle for separating gold. The final stage deals with the byproduct of the previous steps: wet, saturated tailings. You cannot discharge this water directly into the environment. Most countries have strict standards that tailings must meet before they are released. A dry stacking system solves this. Using hydrocyclones or dewatering screens, the plant removes the liquid from the solid waste. The hydrocyclone spins the tailings to separate the water. The solid waste is compacted for dry stacking, while the capture water is recycled. Returning this water to the beginning of the plant satisfies the high-volume requirements of the first stage without creating an environmental liability. At the end of the process, you have two distinct products: a legally compliant stack of dry sand and a collection of pure gold particles. By following these four stages, the initial crushing and desliming, through separation and final dewatering, this process achieves a recovery rate of more than 90%. If you are looking to implement these solutions for your mine, contact our service team to design a processing line tailored to your specific site. Consistent gold recovery depends on the mastery of these mechanical separation stages.